So I'm going to be going over my presentation for secure coding. To start with, I'll go over just the things I'll be looking at. As far as the standards, I'll be looking at limiting accessibility, validating your inputs, not repeating code, not revealing the implementation in your error messages, and keeping your implementation relatively simple. To start with, by limiting accessibility, that is classes, interfaces, methods, and fields should all have the minimal accessibility they need. So what that means is putting private or public versus protected on all of those, on your classes, interfaces, methods, and fields, and the proper way. So you don't want something to be public if you don't need everything to access it. If accessibility isn't properly considered, that data can end up in unwanted locations. So in the next slide here, I have some examples. You can see over here, I have public class student, and that student class has a string name and an integer age. Both of those fields are set to public right now. If this is the case, then down here you can see when I declare a student object, I can say student.name equals, and then make it completely blank, or student.age, and set that to be 2005. Well, obviously you don't want to be able to set their age to nothing, or excuse me, set their age to 2005 and set their name to be nothing. So in this case, you would want that private string name and the integer age, you want those fields to both be private so you can't access them from outside. You can see here I've got an example of how you would properly allow those to be set. You set name with a string, and then you put your input validation, which I'll go over here, and you set age, input validation, and then you set the age. So you don't just allow someone to set it to be whatever they want. On that topic, next I'll have validating inputs. So it's important to understand that no data can be trusted, not your own data, not external data, and especially not user input data. If you trust data that shouldn't be trusted, then you're allowing data into your program and into your software that shouldn't be there. To validate an input, you need to make sure that the data is what you can accept it to be. So for example, a string, if you know what SQL is, you don't want an SQL statement to have just put a string in the middle of that, because then someone can do SQL injection. If this isn't done, a user can input whatever they want and likely break an application. So input a string when it should be an integer, for example, the application just crashes. An example of that is pretty much exactly what I just said. So I've got a class over here called getUserInput, and all it does is return the next line from the console input. You can see I'm getting user input here as 1 and user input here as 2, and then I'm trying to set a value to multiply those two. I want this value to be those two multiplied. If a user input hello instead of a number for this, it would return that number and try to multiply, or excuse me, it would return hello and try to multiply that by the other input, and that would just cause the program to crash. You've got all kinds of errors in this. So it should be done. As you can see, I've got a public static get valid int over here that returns an integer value. And all this does is keep probing the user to try to get a correct value type. And then this won't error out because you have the correct value types. It's also important not to repeat yourself. So to make sure that the same operations are done on data every time. You don't want, for example, multiplying two integers, you don't want that to be done different ways every time, because then you have no commonality. You don't know exactly what's going to happen to that data. This concept can also make code more readable, and ignoring it can lead to inconsistent and often incorrect information. For my example here, I've got distance. It's this method gets the distance between 2 points. So you've got a double that's the change in x and a double that's the change in y, and it's just doing the math for that, and it's returning the square root of those, which is how you find the distance between 2 points. You can see down here, instead of using that distance function for both distance 1a and distance 2, the programmer is using the square root of the two added and then squaring them, and then see it's the same thing that's happening up here, but he's doing it separately. This, you can see, it's really confusing. Like, why do they have this here for distance? Why do they have this here for distance 2? What you should do instead is set this distance function to take an x value, a y value, an x value, a y value. So you can do something really simply, and you can do the distance between ball and 1 and ball 2, but just their values. In this case, you can reuse this code for a lot more things. So I can find the distance between things that aren't necessarily points. And it obviously makes it a lot more readable. It's important to not reveal the implementation through error messages. So error messages are extremely useful for debugging, obviously, but they can allow attackers to understand more information than they really should. So ignoring that can give someone a glimpse inside of your program when they shouldn't really have access to that. So I've got here a method that just multiplies two double values as inputs. And you can see it'll multiply those, and then it'll try to return that value as a string. And when that doesn't work, it'll say could not convert from that value to a string in this function. And you can see an example of that down here. This is extreme and clearly incorrect implementation, but you can see that when this function errors out, it'll reveal exactly what's occurring inside of it. That's not going to be an issue in this case necessarily, but if you've got a complex program that's dealing with important data, you don't want to reveal exactly what's going on inside of that function. Over here, I've got a correct version of that. So instead of printing the error and then saying could not convert from inside this specific function, it's just saying formatting error. So as a programmer, you know where that formatting error is, but as someone who isn't supposed to have that information, it doesn't give you anything more than it needs to. And then keeping your implementation simple is arguably one of the most important things. Complex implementations can be fun to look at and can sometimes be more efficient, but they're also far more prone to errors and manipulation. If you've got something that's really complicated, and it might work for some things, but it's hard to tell exactly what's going wrong because it's harder to pinpoint. By ignoring this, you make code much harder to read, and you introduce undesirable possibilities. So for example here, I've got a switch statement that case 1 is Monday, case 2 returns Tuesday, case 3 Wednesday, and I've excluded all those here, but then the default is to throw this error message. In this case, you have 8 different switch cases, 8 different return statements, and it just gets really complicated and unnecessary. On the right here, I have a much more simplified version of that. If it's not if it's not between 1 and 7, throw it out, and if it is, just pull a day from this string array instead of returning this if it's this, returning this if it's this. So you can see why this is much simpler than this. Some common vulnerabilities are injection, broken authentication, sensitive data exposure, and security misconfigurations, and I'll go over those here in more detail too. Injection flaws such as SQL, NoSQL, OS, and LDAP injection occur when untrusted data is sent to an interpreter as part of a command or query, and that's from the OWASP top 10. So all that means is when you accept data that you shouldn't accept, a bad actor can use that in ways you don't want them to. This vulnerability is primarily caused by lack of input validation, which I mentioned earlier. Preventing injection is actually pretty simple. It can be prevented by just validating user input and ensuring that no directly harmful data is accepted. So for SQL, again, if you know what that is, parameterizing your SQL statements instead of just smashing 2 strings together can save you from that. Another common vulnerability is broken authentication. So, and from OWASP top 10, application functions related to authentication and session management are often implemented incorrectly. All that means is that when you're trying to make sure that someone is who they say they are, you're doing it incorrectly. So this vulnerability is caused when a program does not properly verify a user who is who they say they are. This is largely tied to limiting accessibility that I mentioned earlier as well. To avoid broken authentication, again, it's relatively simple. You just need to ensure that your trusted internal data is kept completely separate from your untrusted external data, and that way you don't end up mixing bad and good data. Another common one is to expire sessions after a certain amount of time. So for example, when you get kicked out of Blackboard because it tells you your session expired and you need to log back in. When sending information over the internet, it's always important to use secure protocols as well. So instead of using HTTP, use HTTPS. Another vulnerability is sensitive data exposure. And again, from OWASP, many web applications and APIs do not properly protect sensitive data. This is when your data that is meant to be internal or private is exposed unintentionally or just not properly secured. This can be caused by a number of things, including failure to properly limit the error messaging, as mentioned earlier, as well as limiting accessibility. This one's pretty self-explanatory, so to prevent it, it's similar to the previous vulnerability. It can be prevented by ensuring communications are done over secure protocols. So again, HTTPS instead of HTTP. It's also important to ensure your cryptography is strong and use secure keys. So your passwords aren't being sent in plain text over the internet. They're actually encoded in some way. And on that note, it's important to never, ever hard code any credentials into a program. So you always have a config file somewhere else that you're reading from so that if someone gets access to your code, they can't just see this is your password, this is your username. And then finally, security misconfigurations. This is commonly a result of insecure default configurations, incomplete or ad hoc configurations, open cloud storage misconfigured HTTP headers, and verbose error messages containing sensitive information. That's again from OWASP, and you can see immediately verbose error messages is the revealing implementation in error messages that I was talking about earlier. As you can see, one of the causes of this is that implementation in error messages. Another very common cause is leaving default configurations and not properly updating your software. That can't be stressed enough. To avoid security misconfigurations, you just need to properly update your configurations for libraries and APIs. So any API or library you use that may not necessarily be trusted always needs to be kept up to date, always. It's also important to add many layers of padding so that if one layer fails, there's still another layer of security. So if your front line fails, that doesn't immediately give an attacker access to the back. You also need to thoroughly check all configurations. So every configuration you have needs to be completely checked to make sure that it is accurate and, just more importantly, not default. Here are my resources used. You can see there they all are. And that was my presentation over secure coding. I hope you learned something, and I hope you appreciated it.